my name's Benedict. I'm the first author of this paper titled World of Bugs, a platform for automated bug detection in 3D video games. So I'm doing my PhD at Royal Holloway, University of London, and I'm here to talk about the platform that we've been developing. So first, I'm going to talk briefly about what automated bug detection is, and then introduce the platform briefly, and then we'll go on to a short demo. But I encourage you to look at the website and kind of play around with the platform yourself to get like a real idea of what we're doing and what the platform's about. Okay, so what is automated bug detection? It's a facet of automated game testing where we're interested in these two kind of sub-problems. So there's this game playing or exploration problem where traditionally a human game tester will go in and play the game, or maybe a team of testers will go in and play the game. They'll play it many times and try and search the whole kind of play area, fight all the enemies, do all the things that a normal player would do to try to find bugs in the game and then report those bugs. There's the exploration problem, and then there's this kind of additional problem, which is identification. That's kind of not talked about so much because the human testers are able to kind of do this by default. So they kind of know when something doesn't look right. They might follow a specification, and sometimes it might not be so obvious, but generally it is. So with these kind of visual issues that we can see, it's pretty obvious to a human game tester that these are issues. But for an automated system, it might not be so obvious what the issues are, and we need to tell it what the issues are. So one of the kind of basic kinds of automation is just to write scripts that do exploration and identification. So for exploration, we write essentially a behavior or an agent behavior that completes the level or wanders around the level and does whatever we want it to do. And obviously, this kind of varies in its difficulty depending on how complicated the game is that we're interested in testing. Typically people will kind of break it up into sub-problems. So maybe just have an agent that deals with one part of the game and kind of explores it somewhat thoroughly, and maybe avoids some of the more difficult puzzles and leaves those to be tested by a human. For identification, we might have a series of conditions that are checked maybe at every step in the game. So here we have just a simple check that asks whether the player is currently in the bounds of the level, and if they're not, then it's going to throw an error and alert the tester or the developer. So developing explorative agents is difficult, and not all bugs can be dealt with in this way. Like, we really need the human tester to do some of this. So the kind of next step from this rule-based or more traditional kind of automation is automation with AI. So there's been some pretty significant advancements in developing agents for game playing. So probably people have seen the work on playing games like StarCraft and these really challenging games. And there's also been some advancements in identification, methods for identification with AI, like in machine vision, and particularly for kind of anomaly detection in video and in images. And I should say that this automated bug detection with AI is still in this kind of infancy stage. There's not that many works that look at this problem, particularly the identification problem, although it's starting to get more attention. But the promise is to revolutionize video game testing. So there's some pretty clear advantages from having for automating this. So where does our work kind of fit in all this? So unfortunately, there are many barriers to entry for researchers. So particularly for the AI community, games are often closed sourced. So you kind of need to make your own game which I've kind of found myself doing essentially, and that's how this platform's kind of come about. And this takes loads of time. If you already have a game by chance, like if you're working in industry or something, then reliably reproducing bugs can be difficult. You might have to kind of dig through loads of source code and try and find, where there was a bug and then replicate it and ensure that when you're testing your bug detection system, that you're doing it correctly, basically. And integrating these kind of sophisticated automated bug detection agents, so integrating reinforcement learning, for example, into a game is not so easy, because you might be relying on deep learning or something, and you need all the libraries associated with that. And then like labeling is another problem. So if you're trying to do, if you're using supervised learning, for example, for doing bug identification, then you need data sets which are labeled to say, what is a bug and what isn't a bug. So our platform aims to address these problems. So World of Bugs is a platform that supports this kind of ABD research, and we're trying to remove the barriers of entry, and we're trying to standardize the process. So a lot of the recent works on automated bug detection, they're kind of disjoint. They all use their own games, their own kind. They're looking at different kinds of bugs, and it's really difficult to compare and to see what what approaches are good and what approaches need some work. So the features kind of currently in the platform, so there's a growing collection of games. The games are really simple, so they're hardly even games. They're just simple kind of test environments that an agent can kind of walk around in and look around in and maybe solve like a puzzle or something. And then a growing collection of bugs that can be added to new games that one might create, or to some of the existing games in the platform. It also has support for learning-based exploration and identification. So we've got a system for labeling different kinds of bugs, and this kind of Python API that is based on top of, or based on Unity's ML agents package, which lets you connect to the Python machine learning ecosystem. So I'm going to go over to a demo and just quickly show what the platform is and how one can get set up using it. Okay, so welcome to the demo. We're just going to show what the platform looks like inside the Unity editor. And I'm going to control the agent with my keyboard, and I'm going to enable and disable some bugs just to kind of give you an idea of what's going on. So I can move and look around. If the agent goes too close to a wall, then it's going to see this camera clipping bug, which allows it to see through walls, and this is going to be rendered also in a mask, which tells the agent where, in its observation, there's an issue. So we've got a couple of different bugs enabled. There's the camera clipping, but there's also this geometry clipping, which lets the agent walk through a wall. I can disable the bug just by clicking on the tick box, and then the agent is kind of no longer able to walk through the wall. I can enable some other kinds of bugs, so maybe this missing texture bug, again, it's rendered in the bug mask, and I can add like new kinds of bugs just by maybe add a geometry corruption bug. I just need to set the color of the bug, so whatever we want it to be. I can make it non-static, and then maybe add a game object to the bug. So I've added the whole level to it, and if I turn the bug on and off, then we can see in the game view that there's some game object in there that's now corrupted. And the agent can like wander over there to try and find where that is, and hopefully be able to identify it with its sophisticated identification mechanism. Okay, so there it is rendered in the bug mask. So we're looking for contributors. Have a look at the GitHub. Download the platform and have a play around, and get a feel for things. And thanks for watching.